let's go ahead and get started with today's math. Here we go. Numbers 1 through 8, the directions say to use the sphere at the right. In our case, we're going to use the sphere at the bottom of the page. So here we go. Name a chord of the sphere. Now a chord is a segment that runs from one part of the, one edge of the sphere to the other side, okay? So I see QS. I see, TR. What else do I see? QS, TR, and ST also right here in front of me. Now you kind of look at ST and you're like, is that really a chord? Well, yeah. I mean, it goes from one edge of the sphere to another. So any of those three would be sufficient. Any one of those three are acceptable. Alright. Okay, moving on now to number 2. Number 2 says name a segment that is a radius of the sphere. Alright, a radius. Well, guys, look. A radius is a segment that starts at the center and goes to the edge. So PR is a radius. Also, PS is a radius. And also PQ is a radius. So any of those three would be totally fine, okay? Any of those three. A radius runs from the center of the sphere to the edge. Name the center of the sphere. Well, it's P. P is the center, alright? Name a segment that is a diameter of the sphere. In other words, where is the diameter here? Well, students, the diameter has to run from one edge of the sphere to the other and pass through the middle. Now, TR definitely runs from one edge of the sphere to the other, but does it go through the middle? Obviously not, okay? But QS goes from one edge of the sphere to the other, plus it runs through the middle, so QS would be your diameter, alright? Let's see what else we have here. Find QS, the length of one. Oh, come on, guys. Common sense, okay? The radius from P to R is 3, correct? So the diameter would have to be 6. The diameter is always twice as big as the radius, so the answer would have to be 6. Alright, moving on to number 6. Find the circumference of the great circle. Now, remember the great circle is always the circle that's right in the middle of the sphere, that cuts the sphere into two hemispheres. Let me say that again. The great circle is the circle right in the middle of the sphere that cuts the sphere into two hemispheres. Alright? So we're going to find the circumference of this circle. Now, guys, look, we know that from here to the edge of the circle is a radius of what? 3. We know that. So even though this circle looks kind of smashed, if you were to get above this glass sphere and look down, you would see a circle right here in the middle that has a radius of 3. Do you see it okay? Look. If from the center to this edge is 3, then definitely the center from here to the edge has to be 3. So if the radius is 3, the diameter would then be 6. Why does that matter? Because circumference is pi d. So I'm going to take 3.14 times the diameter, which is 6, and you'll get 18.84. 18.84. Alright. Moving on to number 7. Find the surface area of the sphere. Alright. Find the surface area of the sphere. Well, surface area is right here. The formula is right here in front of us. Okay, so because of that, let me slide it over just a little bit. My pen seems to work a little better right over here. The surface area of the sphere is right here. The formula is right here, so we're going to take 4 times 3.14 times radius squared. Now the radius is 3, so 3 squared. Let me take my good old calculator here, held together by tape, and let's see, we have here 4 times 3.14 times 9, 113.04. Now that's going to be the surface area of the sphere. the same answer, which is 113 point 113.04. Now I didn't see that coming, and I'm trying to figure out why we're getting the same answer. Pull this over here real quick. I would think that 3, okay, when you're putting in 3 right here and squaring it, you get 9. But then over here, when you multiply, yeah, that's got to be it. That's only going to happen when the radius is 3. So the volume and the surface area of a sphere, and I should have known that, will only happen, they're only going to be the same. The surface area and volume of a sphere will only be the same when your radius is 3 or your diameter is 6. And here's why. Think about it. Let's break this thing down. I have 3, I have 4. They both have a pi, so cross that off. Alright, now, we have a 4 left and an r squared, a 4 thirds, and an r cubed. Now, if I put 3 in here, I have 4 times 3 times 3. Over here, I have 4 thirds times 3 times 3 times 3 because 3 cubed. But look, guys, 4 thirds times 3. If you took 4 thirds times 3 right here, you would get 4, which is 4 times 3 times 3, the same as this. So some of you understand that, some of you don't. The point I'm trying to make is it'll only work with 3 because 3 is the only number here that's going to cancel out with your denominator here, this 3 here, to then leave you with a 4. Okay, so anyways, but what they wanted you to do is find the surface area. We did it, and then find the volume, and we did that. Alright, so moving on to the next set of problems, numbers 9 through 12. First of all, find the radius of the sphere. Now, I think they give us, let me look at my book, yeah, they give us some information I should have written down here. They tell us the volume is 32 over 3. Pi cubic inches. Now, I don't really care a whole lot about the cubic inches right now, as long as I realize my answer is going to be in inches. Now, there's the volume, so they want us to find the radius. Now, guys, think about it. They're giving us the volume, so we wouldn't use this formula right here. We would use this formula here because that's the formula that deals with volume. Okay, so volume equals 32 over 3 pi. So where v is right here, I'm going to put 32 over 3 pi, and then I'm going to say equals 4 thirds pi r cubed, and they want us to solve for r, find the radius. So where v is, I put this because v equals this right here. That should make total sense, okay? Alright, now, let's just do some common sense. If I divide both sides by pi, divide this side by pi, and divide this side by pi, I'm left with 32 over 3 equals 4 thirds r cubed, okay? Now I'm trying to get r by itself, so next, if I divide both sides by 4 thirds, let's go back up here to our first step. Why did I divide both sides by pi? Well, look, you're trying to get r all by itself, are you not? Sure you are. So you want to get rid of your 4 thirds, and you want to get rid of your pi, okay? Well, I decided to get rid of pi first, so I divided both sides by pi. Alright, hold on 1 second, please. Did not mean to do that. So I divided both sides by pi, okay? Now, after I do that, then I'm going to divide both sides by 4 thirds. So 32 over 3 divided by 4 thirds. Use a calculator if you need to, guys, okay? I can do it over here for if you want to see it. 32 over 3 divided by 4 thirds. Remember, when you're dividing fractions, you flip it and multiply. So now it's 3 fourths. Your 3's would cancel. Your 4 would go into 32 8 times. 8 times 1 is 8. 1 times 1 is 1. So 32 over 3 divided by 4 thirds is 8. 8 equals r cubed. Take the cubed root of both sides, and the cubed root of 8 is, take the cubed root of both sides. Now, why would we take the cubed root of both sides? Well, I'm glad you asked that question. If I had r squared, I would take the square root of both sides, right? Sure I would. Well, if I itself, I'm going to take the cubed root of r cubed. The cubed root of r cubed is r. But if I take the cubed root of one side, I've got to take the cubed root of the other side. The cubed root of 8 is 2. How do I know it's 2? Because 2 times 2 times 2 is 8. So the cubed root of 8 is 2. So there's your radius. Your radius is 2. Now, what is 2 inches? Now, what is the top half of the sphere called? We've learned. Well, first of all, let me look at the directions. I think it says, yes, it says in the directions, it says this plane right here, this brown tannish plane contains the center of the circle. So if this brown tannish plane contains the center of the circle, the center of the sphere, then I know it goes right through the middle of the sphere. So with that in mind, what do I call this top half? A hemisphere. It's called a hemisphere. Alright, so there we go. Now, number 11, find the surface area of the top part of the sphere. Then find the volume of each hemisphere. Now guys, come on, think this through. This is really a simple problem. I mean, look, find the surface area of the top half. So let's just simply find the surface area of the entire sphere. And then we will cut it in half, because they want to know the surface area of just the top. So real quick, surface area of the sphere would be 4 times 3.14, and we found the radius right here, times 2 squared. So there we go. Now, if we multiply that through, we would have 4 times 3.14 times 2 is 4, so 50.24. But hold it, that's the surface area of the entire circle. They want to know just the surface area of the top of the circle. If you cut this in half, you'll get 25.12. Okay, so the surface area of the top half, or for that matter, the bottom half of the sphere, is 25.12 inches, or 25.1 inches. Now the next question is, find the volume of each hemisphere. Well guys, they already give you the volume in the directions, remember. If you'll look in your books, they tell you the volume is 32 over 3 pi. So with the calculator, I very quickly just took 32 divided by 3, or 32 over 3, times 3.14, and I got this. So here's the volume, 33 point. Okay guys, I'm back. Sorry, I had a cough there for a second. Okay, 32 over 3 times 3.14 gives you 33.49. 3 repeating. Now that's the volume. They gave that to you in the directions. They told you that's the volume. So this is the volume right here of the entire sphere. So if we cut that in half and divide it by 2, we're going to get 16.74. 16.74. Now I think they're a little off. They have 16.8. Okay, so if we rounded ours down here, we would get 16.7. If we rounded ours to one decimal place, they're getting 16.8. No big deal. And it would be inches cubed because we're dealing with volume. Okay, so guys, there we go. I mean, not too bad. They give you the entire volume. Cut it in half or divide it by 2, however you want to say it, and you will have the volume of the top or bottom hemisphere, either one. Alright, let's continue on to number 13. Okay, students, for numbers 13 through 16, we're going to find the surface area and volume. Okay, surface area and volume, pretty simple stuff. And so here we go. Now for the surface area, we would simply have 4 times 3.14 times a radius squared. Radius is 10, so 10 squared. Alright, so with your calculator, or with my calculator, 4 times 3.14 times 100 gives you 1,256. 1,256. That's square inches, and it's square inches because we're dealing with area, surface area. Alright, now let's find the volume of the sphere. Well, we have 4/3 times 3.14 times the radius, which is 10 to the 3rd power. Alright, so here we go. 4/3 times 3.14 times 10 to the 3rd power. Alright, and I'm getting 4,000. exact same thing again. Let's find the next three problems, 14, 15, and 16. Will be pretty redundant, okay? Let's go ahead and find the surface area of this sphere. So we have 4 times 3.14 times my radius squared, which is 2.4 squared. Alright, so grabbing my calculator very quickly, let's see what we come up with here. I'm coming up with 72.3456. 72.3456. I'll just put 3, 5, we'll round there, and that would be square inches because we are dealing with area, surface area. Now let's deal with volume. To find the volume of a sphere, use the formula right here for volume. 4/3 times 3.14. That's a nice 4, isn't it? 3.14 times radius cubed, so 2.4 to the 3rd power. Alright, so let me type that in my calculator real quick. 4/3 times 3.14 times 2.4 to the 3rd power, and I'm getting 57.8764. I'm going to put 57.9 if you round to 1 decimal place. 57.9 cubic inches. Alright, moving on to the next problem, number 15. Once again, we're going to find the surface area and volume of excuse me, this circle right here. So if the diameter is 7, then the radius would be half of that, 3.5. Okay, so surface area is 4 times 3.14 times 3.5 squared. 4 times 3.14 times 3.5 squared, and I'm getting 153.9 if you round to 1 decimal place. 153.9 square feet. Square feet. It'd be square feet because we're dealing with surface area. Now on to volume. Volume would be 4/3 times 3.14 times 3.5, the radius, to the 3rd power. So here we go. Let's see. Type in 3.5 here, and I'm getting 179.5, and the answer is 179.6. So we're off just 1/10, and that would be feet cubed, okay? Because we're dealing with volume. Volume is a cubic measurement. Number 16. Last one in this section. We'll move on to something else, alright? Here we go. Now, if the diameter is 12, the radius would be 6. So to find the surface area, I'm going to take 4 times 3.14 times radius 6 squared. Okay, taking my calculator here, multiplying these together very quickly here. Let's see what we get. We get 4 times 3.14 times 6 squared. And I'm getting 452.2. 452.2. And that would be feet squared because we're dealing with surface area, and area is always square measurement, okay? Now for the volume, wow, it's a nice arrow. We're dealing with 4/3 times 3.14 times 6 to the 3rd power, alright? So let's see what we have here. Let's go with, let me change this real quick here. If you type this into your calculator correctly, I'm getting 904.3, and that is the correct answer. 904.3 cubic feet. Alright, there we go. Plain and simple. Now number 17 through 20, the directions say to complete the table, so no problem. We'll be doing the same stuff all over again. So here we go. First of all, they tell us the radius is 7. They want us to find the circumference of the great circle. Are you ready? So remember the formula for circumference of the great circle is just pi d, okay? Because even though it's called the great circle, it's still a circle. And if you're trying to find the circumference of a circle, the formula is pi d. Now, don't forget this, guys. Watch my horrendous drawing here, okay? Look, if the radius of this thing is 7, like they say right here, 7, well, that would mean the radius also from here, from the center of the sphere to the edge of the sphere is 7, but that also means the radius of the great circle is 7. So all I'm trying to show you is one simple thing. The radius or diameter of the sphere will always be the same as the radius or diameter of the great circle. I think that needs to be said again, okay? The radius or the diameter of the sphere will always be the same as the radius or the diameter of the great circle. So if we're going to find the circumference of the great circle, the radius is 7. If the radius is 7, then the diameter would be 14. So I'm going to put 3.14 times 14. That will give me the circumference of the great circle, which is 43 point, I think they have theirs. Let me look. I'm trying to locate the answers here so I can check my work. I'm not seeing it here in the book. Yeah, okay, that's fine. Anyways, the answer would be 43.96. Let me change colors here. 43.96. All right, that would be millimeters. That would be the circumference. Okay. Now, let's go ahead and find the surface area of the sphere. So very quickly, 4 times the radius, 4 times 3.14 times the radius squared, 7 squared, and that would give me 4 times 3.14 times 49, 7 times 7 would give me 615.44. So 615.44 square millimeters. Square because we're dealing with area. Now the volume of this sphere would be 4/3 times 3.14 times radius, which is 7 to the 3rd power. So 7 to the 3rd power. So here we go. Parentheses 4/3 times 3.14 times 7 to the 3rd power would give you 1,436. 1,436.03, and that would be cubic millimeters. Cubic millimeters because we're dealing with volume. All right, let's go on to number 18 now. They give you the surface area. Do you see that? Now look, guys, listen to me so very carefully. The radius is the key. If you can find the radius, then you can find any of these other things over here, okay? So for the next 3 problems, they don't give us the radius, but that's the first thing we're going to find is the radius, okay? So the surface area is 144 pi, so I'm going to put 144 pi equals 4 pi r squared. So where the S is for surface area, I put the surface area, which is 144 pi. Now we're solving for r. So I want to get rid of a 4, and I want to get rid of my pi. The first thing I'm going to divide by is my pi. So if I just use your imagination, guys, if I divide both sides by pi, the pi is just gone. So I'm left with 144 equals 4r squared. Now divide both sides by 4, okay? And if you do that, you're going to get 36, I believe. I say, yeah, 36. Now we're going to divide both sides by 4, and we get 36 equals r squared. Now if you have r squared, and you want to make it just r, you take the square root of it. But if you take the square root of one side, you must take the square root of the other side. So the radius is 6. So I'm going to put radius equals 6, diameter equals 12. And now we are so ready to roll, okay? So here we go. We're going to find the circumference of the great circle. Circumference is pi d, and the diameter is 12. So 3.14 times 12. Grab my calculator real quick here. 3.14 times 12 is 37.68. So 37.68. And we're dealing with inches. See that right here? Inches. So, inches. Alright, there we go. Now, let's go ahead and find the volume of the sphere, okay? The volume. And I'm going to fix something on my calculator real quick here. So, hold on 1 second, please. Okay, students, I'm back in. Here we go. Volume of a sphere. Okay, here's the formula right here. All we need is the radius, and we know the radius is 6. So 4/3 times 3.14 times the radius cubed, 6 to the third power. Now, 6 to the third power is 216, and then multiply that by 4/3 and 3.14, and you will get 904.32. 904, sorry guys, the pen is messing up. 904.32 inches cubed. Alright, moving on. Now, let's take a look at number 19. Number 19. First of all, they give us the circumference. Now remember guys, what is the key to solving all of these? Radius, 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 okay? So, the first thing I have to find is the radius. So they give me this circumference right here. So I'm going to have to use my circumference formula, alright? So here it is. Circumference equals pi d. So for circumference, I'm going to put 10 pi, because that is the circumference, okay? 10 pi. 10 pi equals pi d. Now we're trying to solve for d to get d all by itself, because guys, think about it. If I know the diameter, I also know the radius. So I'm going to divide both sides by pi, and I'm left with 10 equals d. 10 equals d. If my diameter's 10, then my radius would be 5 point, not 5 point, that's funny. My radius would be 5. Alright, so there we go. So my radius is 5, and my diameter is 10. Okay, now, having done that, let's go ahead and find the surface area and the volume. Surface area of the sphere would be 4 times 3.14 times the radius squared. The radius is 5, so 5 squared. So I'm really taking 4.4 times 3.14 times 25, alright? And I'm getting 314 for my answer. Surface area, 314 centimeters squared area. Alright. Alright, moving on now to volume. The volume would be 4/3 times 3.14 times radius cubed, 5 to the third power. Alright, so let's go ahead and type this into our calculator, and let's see what we get. 523.3 repeating would be the answer if you type this in correctly. Let's see, centimeters, cubic centimeters. Alright. Okay, moving on. Let's take a look at number 20. Number 20, they give us the volume right here. So we got to find that good old radius, okay? So for volume right here, for V, I'm going to put the volume, which is this right here. So 4,000 pi over 3 equals 4/3 pi r cubed. Now students, listen. This looks really confusing. I understand how it would be, how you would think it might be confusing. Okay, I get that. But let me go ahead and make it a little easier for you to understand, okay? Please watch this carefully. If I have, just forget this problem for a second, okay? Just forget it. Watch over here to the left, see if this makes sense. If I have 3 halves, 3 halves times pi is the same thing as 3 pi over 2. So now let's go backwards. 3 pi over 2 is the same thing as 3 halves pi. Okay? So, using that same mindset, 4,000 pi over 3 is the same thing as just 4,000 thirds times what? Pi. Now that really should make it, in my opinion, a lot easier. And you might say, Mr. Earhart, how in the world does it make it easier? Are you kidding? Now we can see right away. I can divide by pi, divide by pi, and they cancel out. To me, it's a lot easier to see the pi's actually canceling out when you do it that way, okay? So divide both sides by pi, and the pi's cancel out. So now you're left with 4,000 thirds equals 4 thirds r cubed. So now I'm going to divide both sides by 4 thirds. Now guys, you can use a calculator or do it the long way. 4,000 over 3 divided by 4 thirds is the same thing as times 3/4. You flip the fraction and multiply. Well, if you do all of your canceling, trust me, you get 1,000. Now if you want to use a calculator, that's totally fine. No matter how you do it, just get it right. But 4,000 over 3 divided by 4 thirds is 1,000. So I have 1,000 equals r cubed. Now take the cubed root of both sides. Now 10 times 10 times 10 is 1,000. So the cubed root of 1,000 is 10. The cube root of r cubed is r. So the radius is 10. Alright? The radius is 10. And the diameter is 20. So there we go. Now, students, that we have found the radius, now we can easily solve the rest of these problems. First of all, we're going to find the circumference of the great circle. So circumference is pi d. So 3.14 times the diameter, which is 20. Alright? 3.14 times 20, which should be 62.8 or 62.8. So 62.8 meters. Just meters. It's not area. It's not volume. It's just circumference. Okay? So there we go. Now, let's find the surface area. So we have 4 times 3.14 pi times the radius, which is 10, the radius squared. So, typing that into our calculators, we're going to get 1,256. 1,256 meters squared, because we're dealing with area. This was a really good exercise, guys. Very good. Alright, number 25. This is a very tough problem, and I hope you'll give me your undivided attention and listen as I break this down. To manufacture a steel bearing. Now, a bearing is a metal ball, a small metal ball, okay? To manufacture a steel ball bearing, a cylindrical, or a slug shaped like a cylinder, a cylindrical slug is heated. So they take this slug. Notice this is not at all shaped like a ball or a sphere, not at all. Okay? It's a cylinder. They melt it so it's pliable. They heat it very high, to a very high heat, very high temperature, and they press it into a steel, into a spherical shape, and they let the metal cool. Now, the cylindrical slug has a radius of 1 and a height of 2. What is the radius of the bearing? Now, a lot of people would say, oh, that's easy. And boy, guys, you gotta learn to think. If they smash it down, the radius would stay the same. 1. Are you kidding? Not at all. Listen, what doesn't change? The surface area, does it change? Does the fall, what changes with this thing? Well, I'm going to tell you right now, what doesn't change is this. You did not take any metal away. You did not put any in. Do you understand? So the volume does not change. So, if I can find the volume of this cylinder, that will be the same as the volume of this. right? I just said, when you press this thing down, you don't lose any metal. The same amount of metal in this cylinder is the same amount of metal in this ball bearing down here, okay? So, the volumes are the same. So if I can find the volume of this, it'll be the same as the volume of this. Now let's go back a page. We just did a bunch of problems where if I gave you the volume right here, if I gave you the volume, you could definitely find the what? The radius, right? Sure you could. We just did that. In fact, right here, the last problem, number 20, I gave you the volume right here, and you guys found the radius right here, or we did together. So, if you want to find the radius of this bearing right here, then you've got to find the volume. And if you want to find the volume of this bearing, then you better find the volume of the cylinder because they're the same. So, do you remember how to find the volume of a cylinder? If not, let me wonderfully refresh your memory. It's pi r squared h. Hold on a second, guys. Got the old pen acting up like usual. Nothing new there. Pi r squared h. So here we go. 3.14 times the radius squared times the height. Alright, so we can do this in our head, guys. 1 times 1 is 1, times 2 is 2, times 3.14 is 6.28. So the volume of this is 6.28. So the volume of this sphere is 6.28. Got it? So now, I don't need this right here, but I do need this. This is the formula for the volume of a sphere. So where the volume is V, I can put 6.28 equals 4/3 times 3.14 times r cubed. Now very quickly, students, I'm going to multiply 4/3 times 3.14. So 4/3 times 3.14 is going to give me 4.19. So now I have 6.28 equals 4.19 r cubed. I took this times this to simplify. Now divide both sides by 4.19 and we should be doing just fine. I'm getting 1.5, rounded 1.5 equals r cubed. And now students, take the cubed root of both sides. Alright, take the cubed root of both sides and you're going to get 1.144. 1.144 equals your radius. And that would be in centimeters. 1.14 centimeters. Alright, that should be the correct answer. I believe that it is. Yep, we said to take the cube root of what? 1.5. 3/2 is 1.5, and you'll get 1.14. Alright, moving on to number 28. An igloo is a temporary structure built out of blocks of ice. Okay, here's the ground. Here's your igloo. Right here, okay? Now, of course, the actual snow itself is thick. It has a thick wall. So let's have a picture. Here's a little opening here, and Eskimo. Alright, enough of that. So moving on. Now, on a serious note, let's go ahead and see what they want us to do. The structure is a hemisphere, so it's a half of a circle, half a sphere, if you want to look at, okay? Now, the outside diameter is 13 feet. Now, they want us to find the surface area of the outside and the inside. Now, guys, look, let's work on the outside first, shall we? Here we go. We know the outside. Look, guys, follow carefully. The outside diameter is 13 feet. So from this point here, all the way across to this point here, I have a diameter of what? 13 feet, right? 13 feet. So if the diameter is 13, the radius would be what? Half of that, 6.5. So with that information, I am totally able now to find the surface area of the outside of the igloo. So surface area equals what? 4 times 3.14 times the radius, 6.5 squared. Alright, so let's go ahead and do that very quickly. Type that into our calculator, and we're going to get, and I messed up, so hold on 1 second, please. 530.66. 530.66 would be, no, my mistake, I made one little mistake, that is correct. If you type this into your calculator right here, you will definitely get 530.66, but remember, that's the surface area of an entire sphere. We want half of that, because we have half a sphere, so divide that by 2, and you will get 265.3, which is the correct answer. So 265.3, we're dealing with feet, so square feet, because we're dealing with the area, surface area, alright? And that is the correct answer so far, okay? Now, let's take a look and find the surface area of the inside of the igloo. Now, students, be really smart and think this through. Be good, smart students, okay? Learn to reason. We know the distance from this point here all the way to this point here is 13. Now, they tell us the ice or the walls here are 1.5 feet thick. So the little distance from here to here, or in other words, we change colors here, the distance from here to here, that black line right there is 1.5, and the distance from here to here, that little black line is 1.5. So the total distance from here all the way to here is 13. But you gotta take away 1.5 and 1.5, which is 3 feet. 1.5 plus 1.5 is 3. So take away 3 minus 3, you're left with 10. So the distance, the blue line, from there all the way to there is 10. So now we see that the inside diameter all the way across is 10. Now, if the inside diameter is 10, sorry about that, if the inside diameter is 10, then that means the inside radius would be 5, okay? So the radius would be 5. So there we go. So the surface area would be 4 times 3.14 times the radius, which is 5 squared. So let's see what we get if we type all of that into our calculator. 314, no, that's the surface area of the entire sphere, one whole sphere. We're looking for half of that, so we're going to divide that by 2. And we're going to come up with 157. Now it's surface area, so 157 feet squared. Alright, and that is the correct answer. Moving on to numbers 29 through 41, odd. Now, in 29 and 31, they want us to find the area of the intersection of the sphere and the plane. Now listen, we have a flat plane going across here, okay? And if you'll notice, let me move this over so my pen works a little better over here. Now, listen, students, if you have a flat sphere going through like this, or a flat plane, and it intersects a sphere, it's always going to make a circle, okay? So here's the circle. I should use a different color. Here's the circle that is being made. It's right here. Alright, that's the circle. Now, notice what the radius is. The radius of that circle would definitely run from here to here. Would you not see what you have? You have a right triangle, a wonderful, beautiful right triangle. This is the hypotenuse right here. This is a leg, and you're missing a leg right here. Well, I'm not going to do Pythagoras Theorem for you, okay? We've done 101 of those this year, but it would be 3. The radius would be 3. So just like that, I now know the radius of this circle is 3. So how do I find the area of that? Pi r squared, 3.14 times 3 squared, which is 9. Alright, and you're going to get 28.3 units squared. 31's a little trickier, but pay attention, I think we'll be okay. Now, I always have to show you guys the answer. 28.3. Now, look, on this one here, notice that this is the center of the sphere. That's the center. And notice how the plane goes through the center. So if the plane goes through the center, now watch this, guys. That's not what I wanted to do, so if you hold on 1 second, please. Alright, now listen to me carefully, guys. Watch this. This is so cool, the reasoning here. Now, if this plane goes through the center of the circle, then here's my circle right here. It's called a great circle. And I've taught you guys that the radius of the sphere is the same as the radius of the great circle. Now, if that's true, which it is not this a radius right here? Here's the center of the sphere, right? And here's the point that lies on the sphere, right? So that's a radius. Guys, I've got a right triangle again. Look at that. So all I have to do is solve for the hypotenuse, and I will have the radius of the sphere. Now, if I have the radius of the sphere, that's this distance from here, from the center to the outer edge, will be the same as the center to the outer edge. So, if I find the radius of the sphere, that's the same thing as the radius of the great circle. So, here we go. 6 square root of 3, the entire leg is squared, plus the other leg squared, equals the hypotenuse squared. Now, if you square 6, you get 36. If you square a square root, you get the number on the inside. So 3, they're being multiplied, by the way. We know that because 6 times the square root of 3. So it'd be times 3, and then plus 36. Now 36 times 3 is 108 plus 36. 108 plus 36 is 144 equals the hypotenuse squared. Take the square root of both sides, and we have the radius, which is 12. So the radius of the sphere is 12. So the radius of the great circle is 12. So pi r squared is the area of a circle. So 3.14 times 12 squared. 3.14 times 12 squared would give us 452.16. 452. And that would be square units, alright? Or 452.2, they have 0.4, definitely close enough. Now, we'll be challenged on these, they'll be good for you, okay? Number 33, they want us to, number 33, 35, 37, and 39, they want us to find the area of the unshaded part, the volume of the unshaded part, the volume. Now guys, if I can find the volume of this entire cube, and then subtract out the volume of the sphere, then I'm left with the volume of the unshaded part. Does that make sense? If I can find the volume of this the inside of this entire cube, and then find the volume of the sphere, that ball right there, and subtract it out, I have the volume of the unshaded part. So, let's find the volume of the cube. Do you remember how to do that? A cube would be like a prism. Okay, it's a right prism. How do you find the volume of a right prism? We'll look in your notes if you need to, but it's area of base times the height. That's how you find the volume of a right prism. Remember, a right prism is a shape made up of polygons in which the top face is parallel and congruent to the bottom face, and that top face and bottom face are parallel and they are congruent. So we have a right prism. Well, the area, capital B, stands for area of the base. The area of the base would be 12 times 12, which is 144, and then times the height, which is also 12. Okay, so 144 1,728. Now, let's find the volume of the sphere. Now think about it, guys. If from here to here is 12 all the way across, then from here to here, from one glass side to the other, is also 12. So if the diameter of the sphere is 12, then the radius of the sphere is 6. So we're going to find the volume of a sphere when the radius is 6. Right here, okay? So we're going to take this, move this down. That's the volume of a cube. And now let's find the volume of the sphere. So 4/3 times 3.14 times 6 to the third power. So here we go, quickly typing all that into my calculator. I'm going to get 904.32. So 904.32. Now, this is the volume of the entire cube. That's the volume of the sphere. Subtract those two and let's see what we get. 823.68. 823.68. That's volume. So centimeters cubed. That's the volume of the unshaded part. Let me glance at the answers down below. And they're getting 823.2. And we're getting 0.68. So definitely close enough. Alright, moving on to number 35. Well, students, once again, it's the same principle. If we want to find the sorry, students, if we want to find the volume of the unshaded part, we got to find the volume of the entire circle, okay? And then the volume of the entire sphere, and then find the volume of the dark sphere, and then and then subtract them, okay? So here we go. Let's find the volume of this entire sphere. Now the distance from here to right here is 20. See that? So the radius of the big sphere is 20. So come over here. 4/3 times 3.14 times 20 to the third power. So grab my calculator real quick. I'm getting 33,493.3 repeating. Now that's the volume of the big sphere. Now let's find the volume of the smaller sphere. Now we got to find the radius. Now think about it. If from here to here is 20, and that is half of the big sphere, that means then from here to here also has to be 20. So then if that's 20, what's half of 20? 10. So my radius for the little dark sphere is 10. So I'm going to have 4/3 times 3.14. My radius is 10. So times 10 to the third power. Alright, so let's see what we get here. I'm getting 4,186.6 repeating. So this is the area of the entire sphere. This is the area of the smaller sphere. I'm going to subtract those two with my calculator here, and let's see what I get. I'm getting 29,306.7. 29,306.6 repeating. I'm just going to put 0.7, and that would be volume inches cubed. These are pretty cool problems, guys. They're going to make you think. Alright, number 37. Number 37 has nothing to do with spheres at all. We're going to find the volume of this entire cylinder. Then we're going to find the volume of the smaller cylinder right here. And then subtract those two to find the volume of the unshaded part of the cylinder. Alright, so with that in mind, here we go. How do you find the volume of a cylinder? Well, it's pi r squared h. So let's first find the volume of somewhere, times 6 times 3.14, 42.39. 42.39 is the volume of the big cylinder. Now let's find the volume of the small cylinder right here and subtract that out. Okay? So here we go. Now, guys, we're assuming, we're making some assumptions. I don't like to do that, but we're assuming this cylinder, this small cylinder right here, is right in the middle. So if it's right in the middle, then we know from here to here's 3. Well, we know this is a 1. So if it's right in the center, then the distance from here to here has to be 1, too. So if this is 1 and this is 1, then the total diameter right here has to be 1 also, because 1 plus 1 plus 1 is 3. It has to be 3 going all the way across, okay? So with all of that in mind, what I just said, if all of that's true, then that means if from here to here's 1 all the way across, then that means that the radius from here to here is going to be 1.5, half of that. So I'm going to use the same formula. For the radius, I'm going to use 1.5. So 3.14 times, well, it's going to be the same thing, isn't it? Is that correct? Let's see. No, it'd be 0.5. Sorry, guys. I apologize. It'd be 0.5. If from here to here's 1, half of that is 0.5. I know it didn't sound right. 0.5 squared times the height, which doesn't change, 6. So let's see what we have here. I'm getting 4.71. So I have to take the entire volume minus this volume, and let's see what we get. I am getting 37.68 or 37.7 when I subtract these two. 37.7 inches cubed, because we're dealing with volume. Okay, one more problem. This is a good one here, so take a while, but it'll be good for us. Okay, now I wonder if we can twist this a little bit and lay it flat. I think that would help us, maybe just a little. Okay, if we do that. So having done that, I'm gonna cross this off. See this line right here going across? That's 1/2 of an inch. And see this line right here? That is 1/2 an inch. Okay. And then the height right here, the height going up and down, we'll put it right here. The height going up and down is 1/4 of an inch. Alright, now, here's what we're going to do. First of all, if you will listen to me step by step by step, I will explain this. First of all, obviously, we have to find the volume of the entire hexagon right prism, okay? And then we have to find the volume of this gray cylinder, subtract it out. It's obvious. Then you say, Mr. Harry, how are we going to find the volume of this hexagonal prism? Well, guys, look. I have a question for you. Just using the naked eye and looking at this. Here's the top face. Here's the bottom face down here. They're congruent, guys, and they're parallel. So anytime you have a prism in which the top face and the bottom face are, listen to me, congruent and parallel, then you have a right prism. And if you have a right prism, you find the volume like this. Very simple. Area of base times the height. Now the height is right here in front of us, okay? That's the height, and the height is obviously 1/4, okay? So I know the height is 1/4, no problem. What I don't know is the area of the base. So I think it would behoove us or help us greatly if we drew the base over here. So pretend we ripped the bottom face off of this thing and we're looking at it. It would look something like this. Okay, now I'll try not to be too jealous of my drawing skills. Something like this. Now, we know the distance from here to here is 1/2 an inch. Got it? Now, if that's true, then we also know, well, sorry guys, I'm getting ahead of myself. So, we have to find the area of the base, right? Look, right here. To find the volume of this hexagonal prism, we have to find the area of the base and multiply it times the height. Well, we know the height already, okay guys? We know the height already is 1/4. So, is 1/2 times the apothem times the perimeter. Okay? So here we go. We got to find this distance right here. Right there. That distance right there. Before I do that, I want to show you something. If I were to draw 6 triangles in this regular hexagon, they would be 6 congruent triangles, alright? Now, start here, go all the way around, that's 360 degrees, got it? But divide that by 6 congruent angles. 1, 2, 3, 4, 5, 6. Well, that's going to be 60. So they're giving us this angle right here is 60 degrees. Got it? Now, having said that, let's go ahead and erase these triangles. So, if I'm to find the apothem, which is this distance here, then I can draw this right here. I've got to make that triangle a little bigger, okay? Here's my triangle. There it is. Well, this is right. So this is right. From here to here, this whole length is 1/2. So 1/2 of 1/2 is 1/4. So this is 1/4, okay? Now, this big angle right here was 60. Remember, this whole angle was 60. I showed it to you earlier when we drew all these triangles right here, okay? So that whole angle is 60, but we cut it in half when we drew this line right here, right down the middle. So this is 30, that's 90, this has to be 60. So, remember, if this is 30, so your shorter leg is 1/4, okay? Now, if your shorter leg is 1/4, then your apothem, your longer leg right here, is always the shorter leg times the square root of 3. Now I'm going to go ahead and get that in decimal form just to make it a little easier, okay? So 1/4 times the square root of 3 is 0.433. 0.433, alright? So, there's my apothem. Now, my perimeter, this whole side from here to here is 1/2. So this side's 1/2. 1/2. I have 6 of those. So 1/2 times 6 is 3. So my perimeter all the way around is 3. So my apothem is 0.433. My perimeter is 6. Now, because of space, hopefully you've written this down when you erase all this to get some room, okay? So, the area of the base is going to be 1/2 times 0.433 times 6, which gives me 1.29. I'm put 1.3. So the area of my base is 1.3. So now I have 1.3 times 1/4, which will give me 0.325. It's really a weird volume, but that's what it is, okay? Excuse me, it's a really, really weird volume, but that's what it is, okay? So, I have a volume of 0.325. Now, I'm going to check my work, make sure I'm not making a mistake anymore. It looks pretty good. That's my volume of the entire hexagonal right prism. Now, let's find the volume of the cylinder. Well, if this whole line here is 1/2, then the radius would be 0.25. The radius is 0.25, okay? So, with that in mind, radius is 0.25. How do I find the volume of a cylinder? Do you remember? The volume of a cylinder is pi r squared h. So, 3.14 times 0.25 squared times the height, which is 1/4. Let me grab my calculator real quick here. Let's type this in and see what we get. I'm getting this is weird, but 0.049. So this is the volume of the whole hexagonal right prism. This is the volume of the cylinder. We're going to subtract those two, and I'm getting 0.27. Now hopefully I've not made a mistake on that, but 0.27, alright? so 0.275. And that would be cubic inches because we're dealing with volume, okay? Alright, now moving on to last two problems, and we're finally finished, okay? Now, if the sphere of a radius r is inscribed in a cube, what is the ratio of the volume of the sphere to the volume of the cube? Now, instead of my trying to draw this, I'm going to steal this picture right here, and we're going to use this. Alright, let's grab this, let's do this, let's copy it, and let's come back to here, and let's paste it. Now, this is a really good picture of what they're talking about, okay? Now, only thing we're going to do is we're going to white out these things here. We don't care about any of these measurements at all, okay? In fact, I think what we'll do, well, we'll leave it like this for now. Now, it's okay, guys. I think we will go ahead and use those measurements, okay? Because it really doesn't matter. We're calling it radius r. It really doesn't matter what you call the radius, as long as you're consistent. So let's go ahead and use this. Listen to me carefully, guys, and watch this. We want to know the ratio of the volume of the sphere to the volume of the cube. So in other words, ratio means I want volume of the sphere over volume of the cube. Got it? Now, in fact, actually, there's really a fast way to do this, and I hope this doesn't confuse you guys, but you know what you could do, guys? They're telling us the radius is the same, because look, if you have a sphere inside of a cube, then the radius has to be the same. The radius of the sphere will be the same as the radius of the cube. So to be honest with you, I'm just going to leave radius r. Watch this so very carefully. Here's my sphere. What's the volume of a sphere? 4 pi r squared. What's the volume of a cube? 4/3 pi r to the third. Just reduce this and you'll have the ratio. Well, Mr. Eric, we don't know what the radius is. You don't have to. I don't care if the radius is 1, then both of these will be a 1. If the radius is 5, then both of these will be a 5. If the radius is 7, then both of these will be a 7, because the radius is the same. How do I know the radius is the same? Because it says the sphere is inscribed in a cube. So if the sphere is inside of a cube, think about it for a second, guys. The radius of the sphere from here to here to the side has to be the same as the radius of the sphere. So the radius is the same. So first of all, cross off your pi's. Got it? Next of all, we have r squared over r to the third power. Okay, guys, I was working this out, and we need to go back to this right here. And I do hate that, but it happens, guys. We've had a really good homework video, but sometimes these things happen. Right here, guys, made a mistake. The ratio of the volume of the sphere to the volume of the cube. Well, the volume of the sphere right here is 4 pi r squared. The volume of the cube, of course, is going to be, well, I'm trying to think of the best way to say this. If you look at it carefully, please watch this, students. It's a cube, so we know we're going to take the area of the base times the height, right? How do you find the volume of a cube? Area of the base times the height, or 12 times 12 times 12. Now, would you please think about this? If the side is 12, then the radius here would be 6. I know we're not using numbers yet, but just watch this and see what happens, okay? Alright, here we go again for the third time. This is a lovely way to end the video, guys, okay? Volume of sphere to the volume of the cube. This will go down in history as probably the worst problem ever that I've showed you guys how to do. Alright, here we go again. Volume of sphere would be 4/3 pi r cubed. means this entire length right here is 2r. r plus r. You have a r here. From here to here is r. And from here to here is r. So this whole side would be 2r. I hope you see that. So really, the volume of the cube would be 2r times 2r times 2r. Remember, area of the base, side times side. So we would have 2r times 2r. Area of the base times the height. I know I've done a very poor job of explaining this, but hopefully you'll understand this. So next we're going to have 4/3 pi r cubed over 2 times 2 times 2 is 8. R times r times r is r cubed. Okay, now let's go ahead and get, now that I'm totally done with this picture, let's go ahead and get rid of it. We have some room to work with here. If I can slide this thing over, there we go, and slide this over, there we go, and slide this up, and hopefully we can get this done. I do apologize again for the mistakes. Now, your r cubed over your r cubed will cancel out, so now we're left with 4/3 pi over 8, okay? Now, earlier in the video I showed you guys that 3 pi over 2 would be the same thing as just 3/2 pi. So 4/3 pi over 8 would be the same thing as 4/3 over 8 pi. Now with a calculator, or not with a calculator, it's up to you. If you take 4/3 divided by 8, let's see what we would get here. We should get 1/6. So listen, students, if you take 4/3 with the calculator divided by 8, you will get 1/6 pi. And of course 1/6 pi is the same thing as simply 1 pi over 6, or I just say pi over 6. And if you're looking in your books, that's answer letter C. That's probably the worst job I've ever done a problem. I apologize, but you know, nothing I can do. So back it up. I would back it up if you need to and watch it again from the part where it was correct, okay? I kept putting in the wrong formula for this, then the wrong formula for this, and that was the mistake, okay? Alright, moving on to number 42. The water level of a 40 by 70 swimming pool is raised 3 inches. How many gallons of water were added to the pool, okay? So here's the pool. We're just going to say it's we're going to say that it is 40 by 70. So 40 by 70. Let's label this 40. We'll label this 70, and then we're gonna just get a little snapshot of the 3 inches. So 3 inches, okay? Now, how many gallons of water added? So that we're gonna pretend it's the little bit here that we're adding. Now, first of all, be careful. We got 40 feet, 70 feet, and 3 inches. Everything's got to be the same. So I'm gonna take 40 feet real quick and multiply that by 12, and I'm going to get 480 inches. 480 inches. Now I'm going to take 70 times 12, and I'm going to get 840, alright? 840 inches. Now we can very quickly find the complete volume of this part of the pool. The area of the base is 480 times 840, so 480 times 840 would give me 403,200, okay? And then multiply that by 3, so times 3, and that's going to give me this. Are you ready? 1,209,600 cubic inches. Alright, now be very careful here. I remember teaching the juniors this in 8th grade math. Anytime you're converting cubic to cubic or square to square, if you're converting square feet to square inches, you do the conversion twice. If you're doing cubic to cubic, you do the conversion 3 times. Let me show you what I mean. We have this many cubic inches, 1 divided by 12 3 times. So we divide by 12, divide by 12, divide by 12. Let's get your calculators ready, okay? 1,209,600 divided by 12 equals, divided by 12 equals, divided by 12 equals, and you're going to get 700. So 1,209,600 cubic inches equals 700 cubic feet. Alright, now for every 1 cubic feet right here, every 1 cubic foot, I have 7.48 gallons. Alright, let me say that again. For every 1 cubic foot, I have 7.4 gallons. I have 700 cubic feet. So I'm going to take 700 times 7.48 gallons. Alright, and if I type that in correctly, I'm going to get 5,236. And if you'll look in your book, that's letter C, okay? So guys, really sorry about that last problem. I know that with the video class, you guys count on me to get them right, and I work these ahead, usually, or at least in my head, I do.